Hello, good morning students. In this video lecture we are going to discuss about Hyperlan. Hyperlan is nothing but high performance radio local area network. We simply say that Hyperlan. So first introduction about your wireless networks. So roughly we speaking, there are two types of wireless networks available in the world. First one is local area network, another one is wide area networks. So local area network, the examples are Bluetooth, 802.11 families, Hyperlan families, etc. And wide area networks, we have GSM, 3G, 4G and 5G, etc. Two main standard families for wireless LANs are, we simply say that IEEE 802.11 and EDSA Hyperlan. There are two standard families followed in wireless LANs. One is IEEE 802.11. In IEEE 802.11, we have different types: IEEE 802.11a, B, C, D, E, G, H, like that. And in EDSA Hyperlan, we have different types: Hyperlan type 1, Hyperlan type 2, and Hyperlan type 3 is also called as Hyperlan Access. Hyperlan type 4 will be called as Hyperlan Link. So the below table shows the Hyperlan family differentiations. First we see about Hyperlan 1. In Hyperlan 1, we will use in wireless Ethernet and the frequency range is 5 GHz and the bit rate is 23.5 megabits per second. In Hyperlan 2, that will be used in wireless asynchronous transfer mode. ATM is nothing but asynchronous transfer mode, and frequency range is 5 GHz and bit rate is 6 to maximum of 54 megabits per second. And Hyperlan 3, also called as Hyperlan Access. In Hyperlan Access, it will be used in wireless local loop and the frequency range is same for previous two, 5 GHz only, but the physical bit rate is 25 megabits per second. And in Hyperlan type 4, we also called as Hyperlink. This will be used for wireless point-to-point communications and the frequency range is 17 GHz. The physical bit rate is maximum of 155 megabits per second. These are some of the differentiations between each type of Hyperlans. Then we see about why we use for Hyperlan nowadays. What is the motivation or what is the reason we use the Hyperlans? First, massive growth in wireless and mobile communication. Nowadays all will be having the mobile phone. That is the reason for we use the Hyperlan technologies in wireless LANs. And second one is emergency of multimedia applications. Nowadays all should use the multimedia applications. All will communicate their photos, videos, like that. So emergency applications of multimedia and demands of high speed internet access. All should interested the net access will be very much speed. Then only we can able to communicate our information in a precious time. So due to the demand of high speed of internet access, the Hyperlan technology will be introduced, and deregulations of the telecommunication industry. Next, the history, present and futures of the Hyperlan type 1 and Hyperlan type 2. The Hiperlan type 1 will be developed during the year of 1991 to 1996. The main goal of developing the Hyperlan type 1 is to achieve high data rate than IEEE 802.11 data rates. So main reason for developing the Hyperlan type 1 is we achieve high data rate or high internet speed compared with the IEEE 802.11 and support for asynchronous data transfer mode and carrier sense multiple access with collision avoidance mechanism. Then we are going to see about the next type, Hyperlan type 2. So next generation of Hyperlan family is proposed by ETSA BRON. BRON means nothing but broadband radio access network. So we simply say the Hyperlan 2 type 2 is a BRON network. So broadband radio access network. The main goal of providing high speed of communication access to moving terminals. For roaming terminals, we provide the high speed of internet access. And future is connection oriented, quality of service, security mechanism and high flexibility are available in your Hyperlan type 2. So what are the applications we achieve through your Hyperlan technology means a complement to present-day wireless access system giving high data rates to end users in hotspot areas. So we provide a high data rates to the end users, and typically the environment of office, homes, exhibition halls, airport, train stations, etc. will use the Hyperlan technologies. Different with Bluetooth is which is mainly used for linking individual communication device within the personal area network. The main difference is linking the individual communication device within the personal area network compared with your Bluetooth. Then we see about the Hyperlan 2 system overview. Features are is used for 5 GHz technology up to 54 megabits of bits per second data transfer rate, and it's a connection oriented with quality of services, and security authentication and encryption will be done in Hyperlan 2. So this is the architecture for Hyperlan 1 and Hyperlan 2 types. Thus in first Hyperlan 1 we have a physical layer as a physical layer, and the data link layer we have two types. One is CAC, another one is MAC. MAC is minimum access sublayer and CAC is channel access control sublayer. In Hyperlan 2 reference model, we have the physical layer. So physical layer is what is the use of physical layer? So physical layer is what is the use of physical layer? So physical layer is just we physical layer. So physical layer is just we will receive the data. Physical layer is just we will receive the data. Physical layer is just we will receive the data from the above layer. We will receive the data from the above layer. We will receive the data from the above layer of the data link layer. Receive the data from the above layer of the data link layer, and it will the above layer of the data link layer, and it will the above layer of the data link layer, and it will the above layer of the data link layer, and it will transmit the data link layer, and it will transmit the data link layer, and it will transmit the data to your 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 physical medium. Transmit the data to your physical medium. Transmit the data to your physical medium. The data units of physical layer is burst of a variable length, consists of a preamble and data field. The given diagram shows the physical layer configurations. The PDU is received from DLU. DLC means nothing but we already see that data link control layer. So it will receive the data from the data link control layer, and it have some preamble bits for synchronization the source and receivers, and then it will have some encoding mechanisms for converting the one form of information to another form, and then we have the interleaving bits. Then it will be having the mapping, and then having the modulation. OFDM modulation will be followed. OFDM means orthogonal frequency division modulation techniques will be used. Then we have the physical burst and radio transmitter. Radio transmitter will be transmit your signals. This diagram shows the data link control layer. In data link control layer we have the three main control functions. First one is association control function, second one is radio resource control function, and third one is DLC connection control function. So association control function is used for authentication and key management. Radio access control function used for handover and dynamic frequency allocation, and then DLC connection control function is used for setup and release of user connection. This is all about your Hyperlan. Thank you.